Hi. In this problem, we are going to look at a typical question where we have to find the number of integer solutions to the equation x1 plus x2 plus x3 is equal to 28, such that the variables x1, x2, and x3 satisfy these conditions. Now, what I will introduce to you is the method of the generalized principle of inclusion and exclusion. Principle of inclusion and exclusion. And that is a standard method by which you can solve this problem. So obviously there are other methods also. There is the method of generating functions, but I think this is a more easily understandable way of trying to solve this problem, right? So I'll first introduce the method and we'll solve the problem by using that method, right? So that you get a better sense of how to approach such questions. So what is this method? We say that let S be an n element set, and let P1, P2 till PQ basically be a set of Q properties, for these elements, of S. Right? Now, for each m is equal to 0, 1, 2 till q, we can say what is E of m? What is the meaning of E of m? Is the number of elements having m properties. Which m properties? Any m properties out of the set P1, P2, PQ, right? Em is given by this summation of q goes from m to summation of not over q, it is over k. K goes from m to q, and we have minus 1 to the power k minus m multiplied by kcm and multiplied by wk, where obviously we have to understand what wk is. So this is a summation from k goes from m to q. Q is the total number of properties, and we are counting the number of elements having m properties. So we start with m and go up to q. This gives us an alternating plus or minus sign, starting with a plus first. Because k is equal to m, then it will be minus 1 power 0. Starts with a plus, and after that, as k increases, it keeps alternating from minus 1 and 1, right? And this is kcm wq. wk, kcm is basically just selecting out of k m elements, right? And wk is what we will discuss soon. What is wk? Wk is basically the number of elements of S that have k properties, any k properties. So what I mean by that is, maybe there are some elements of S that have one of these properties. So W1, for example, would be elements having property 1, any one property out of this set of properties, right? So W1 would be W of P1 plus W of P2 plus so on till W of PQ, where we are counting how many elements have P1 property, how many elements have P2 property, and so on till PQ, right? So that gives us the total possibilities of how many elements have only one property from this set, right? So W1 is this. What is W2? W2 will be basically W2 is equal to W of, let's say, P1, P2 plus W of P1, P3 plus W of P1, P4 and so on till W of P1, PQ. Then again W of P2, P3 and so on. So basically, out of these Q properties, there could be QC2 ways to select any two properties, right? and there are many elements which may have P1 and P2 satisfied. So that is what we are counting with W of P1, P2. Then W of P1, P3 would be elements that satisfy P1 and P3. So basically there are QC2 terms in this summation, right? So that is your W2, right? What will be W3? W3 will be QC3 terms like W of P1, P2, P3. So basically all the elements that satisfy P1, P2 and P3. So there will be such terms. There are many terms, QC3 terms, and you will add up all of them. That will be your W3. So basically, what are we counting here? We are trying to count the number of elements having M properties. And we start with this summation, where summation goes from M to Q, starting with a positive sign and then alternating the signs. And we are selecting which elements have M properties out of the K, which elements have M properties, and then WK. We are counting and then alternating. So we are doing inclusion and exclusion here. So it will be very clear with an example. So now we'll work on the original question and we'll take advantage of this generalized principle of inclusion and exclusion, right? So if you are not very sure of how to apply it, we'll just do it with a question now. So let's go back to our original question. The question was x1 plus x2 plus x3 was equal to 28, and we had some conditions. 3 is less than x1 is less than equal to 9. Then we had 0 is less than x2 is less than equal to 8. And finally, we had 7 is less than x3 is less than equal to 17. Now, the first thing I will say here is I don't want this double inequality where both sides are given, right? So 3 is less than equal to x1. So when you have an inequality like this, a lower bound for the variable, it is very easy to transform that equation so that that lower bound is no longer there, right? We can define a new variable y1 as 3 plus x1, y2 as 0 plus x2, and y3 as 7 plus x3, right? Now we can say that y1 should be less than equal to, basically it is from 0 to 6, right? Y1 can be from 0 to 6, correct? No, I have made a mistake here. Y1 is not 3 plus x1. We can say x1 is what we are replacing. X1 is equal to 3 plus y1. So that y1 starts from 0, right? Here y1 will go from 0 to 6. And x2 will be simply y2, and y2 will go from 0 to 8, right? And x3 would be 7 plus y3, and y3 will go from 0 to 10, right? So now we can say that the equation transforms into 3 plus y1 plus y2 plus 7 plus y3 is equal to 28. So basically this becomes y1 plus y2 plus y3 is equal to 18, where we have the restrictions that y1, y2, y3 are positive, could be 0 also, could be 0. And you have only upper bounds on them. Y1 should be less than 6, y2 should be less than 8, and y3 should be less than equal to 10, right? So this is the equation that we want to solve. And how many ways of doing this? So if you have no restrictions, basically you are not satisfying any restriction, then the number of ways of solving this equation would be 18 plus 3 minus 1 C2. So basically that is, by the stars and bars method, that comes out to be 20 C2 or 190, right? So without any restrictions on y1, y2, y3 is equal to 18, without thinking of these restrictions, the number of solutions is coming out to be 190, right? That is 18 plus 3 minus 1 C2, right? Now we will define some properties. So what is the property 1 that we define? That y1 is greater than equal to 7. Property 2 is y2 is greater than equal to 9. Property 3 is y3 is greater than equal to 11. Why are we defining these properties? Because we can say that we want solutions. We want solutions such that y1, y2, y3 do not satisfy any of these three properties. Any of these three properties, P1, P2, P3. Why am I saying that? Because if they don't satisfy any of the properties, then that means that y1 has to be less than equal to 6, right? Which is what we need. And y2 has to be less than equal to 8, and y3 has to be less than equal to 10. If they don't satisfy P1, P2, and P3, right? So basically, we want the number of elements of the set E of 0, right? Because E of M, if you recall from the principle of inclusion and exclusion, was the number of elements having M properties. Number of elements satisfying M properties. So what are we trying to find? We are trying to find number of elements that satisfy 0 properties, E0, right? Correct. So if I want to calculate E0 so that none of these P1, P2, P3 is satisfied, we will use the rule that we have, the summation. So summation will be from K goes from M is 0 to the total number of properties is 3 minus 1 to the power K minus M. So K minus 0. And then it is KCM. So KC0 multiplied by W of K, right? I will do that on the next screen now. Okay. So this is coming out to be E of 0 is summation K goes from 0 to 3 minus 1 power K minus 0 KC0 into W of K, right? This is so that we count all the elements which don't satisfy either of the three properties. Our equation was y1 plus y2 plus y3 is equal to 18, and our properties were y1 is greater than equal to 7. Property 2 was y2 is greater than equal to 9, and property 3 was y3 is greater than equal to 11. We want to count all elements which don't satisfy either of these. So obviously this summation becomes, when you put K is 0, you get 1 into W0, then you get minus W1 plus W2 minus W3, right? And after that, the summation is over, right? So what is W0? W0 is the set of all solutions which don't have any restrictions. None of these properties are mattering. So that was simply the total number of solutions of this equation, which was 18 plus 3 minus 1, C3 minus 1, or 20 C2, or 190, right? Now we want to calculate W1. W1 will be all the elements that satisfy one of these properties. So it can be counted as W of P1 or W of P2 or W of P3, right? So let's count them individually. How many elements which are solutions of this equation will satisfy P1? P1 is saying that y1 is greater than equal to 7. So the number of solutions for that would be, if you already put 7 in the y1 bucket and you subtract that 18 minus 7, and after that you can say the rest can be greater than equal to 0, plus 3 minus 1 C2. So again, if you don't know how to get this answer, you need to go to a previous video on my channel, which is about the stars and bars method. So in the combinatorics playlist, you will find the stars and bars method, which can help you solve these basic cases. So this will be 18 minus 7 plus 3 minus 1 C2 plus W of P2 will be, y2 should be greater than equal to 9. So how many will satisfy that? So that will be 18 minus 9 plus 3 minus 1 C2. And finally, W of P3 will be 18 minus 11 plus 3 minus 1 C2. So this comes out to be 11 plus 3, 14, 13 C2 plus 11 C2 plus 9 C2. If you calculate that out, that will be 78 plus 55 plus 36. So that is 169. Okay. So that is your W of 1, which is elements that satisfy any one of the properties, right? Now we calculate W of 2 in a similar way. W of 2 will be basically W of P1, P2 plus W of P2, P3 plus W of P1, P3, right? These are the three possible ways in which you can have two properties satisfied, right? So that calculation also is done in a similar manner we'll just do it here. We will get W of P1, P2 by saying P1 and P2. So 7 and 9 are already given to Y1 and Y2. And after that, we can solve it by doing 18 minus 7 minus 9 plus 3 minus 1 C2, right? So this will be 6, 2 plus 3, 5 minus 1, 4 C2. 4 C2 plus P2, P3, 9 and 11 are already given. So it will be 18 minus 20 plus 3 minus 1 C2 plus last one will be 18 minus 7 and 11 are given. So 18 minus 18 plus 2 C2. So this will be 4C2, but this part is 0 actually. And this part is 2C2, which is 1. So the total number of solutions is coming 6 plus 1 is 7, right? So W1 is 169, W2 is 7, and W3 you will realize is W of P1, P2, P3, but that cannot happen simultaneously. If all three are given 7, 9, and 11, you are getting more than 18. So actually W P1, P3 is 0. Number of solutions of that happening is 0. So finally, if I want to calculate my E of 0, my E of 0 will come out as basically 190 minus 169 plus 7 minus 0. So this comes out to be 21 plus 7, 28. So there are 28 solutions which will satisfy the restrictions that were mentioned in the question. Now, the restrictions were having both the bounds, right? There were two bounds to it. So in case you are ever encountering a question like this, you have to do it in parts. You have to do it in two ways. So basically, if you ever see a question like this, right? And you are given x1 is from 2 to 5 and x2 is from 1 to 4 and x3 is from 2 to 7, right? So what is the general strategy that we followed here? So I'm quickly recapping. So first you will remove the lower bounds by saying that the equation can be converted to an equation y1 plus y2 plus y3 and give 2, 1 and 2 already. So 5 is gone. So this is 10. And the number of solutions of this we have to find under the restriction y1 should be less than 3, y2 should be less than 3 and y3 should be less than 5, right? These are the restrictions now, the new question, right? Now we'll define three properties. P1 would be y1 greater than equal to 4. P2 would be y2 greater than equal to 4. P3 would be y3 greater than equal to 6, right? And we are saying that we want to calculate E of 0 again, because we don't want any of these properties to be satisfied. What is the general rule? The general rule is the summation is from K goes from M to Q, and this is minus 1 power K minus M, KCM, W of K, right? But here M is actually 0, right? In more difficult questions, you might have a situation where M is 1 or 2, where questions where any one of these conditions can be true and the other conditions may or may not be true, right? So that is the generalized principle of inclusion and exclusion that we are using. But in this case, it becomes pretty simple. It is W0 minus W1 plus W2 minus W3, right? And then you solve it in the same way as before. W0 is the set of all solutions without any restrictions. So that will be 10 plus 2 C2. So 12 C2. W1 would be the cases when you are already having P1. P1 would be, you already give 4 to it. So it will be 10 minus 4, 6 plus 2 C2. So 8 C2. Plus in this case also it will be 8 C2. And in the final case, you're already giving 6. So it will be 4 plus 2, 6 C2. And W2 would be P1 and P2. You already give 8 to it. So you get 10 minus 8, 2 plus 2 C2. So 4 C2. And P1 and P3, you already give 10. So 10 minus 10 plus 2. So 2 C2. And finally, this case, again, it will be a 2 C2. P2, P3 and P1, P3 are same. This will be this. And W3 would be 4 plus 4 plus 6. So 14, that is 0, right? So the final answer of this question would be 12 C2 minus 8C2 minus 8C2 minus 6C2 plus 4C2 plus 4C2 plus 2C2 twice. 2C2 plus 2C2. So you can count this, and that would be your solution for this question, right? So keep in mind this generalized principle of inclusion and exclusion, and I hope that will be useful for you. What you need to remember is you always have to define the properties of the set first, and after that, see how you can count the number of elements of that set which satisfy only some of these properties, right? So there you have to use this identity. I hope this video will be useful for you. Whenever you have integer solutions types of questions, you can definitely solve it using this. In standard books, at least in India, what you have is they give you solutions, but they're using possibly the generating function method, but they're not explaining how to do it. They'll give you solutions where they will say, find the coefficient of x cube in this expansion product of multiple terms. So they are actually using generating functions methods, but they don't give a proper explanation for that. And anyway, the method of generating functions is a little trickier than what we have just now discussed. So I would recommend that you use the generalized principle of inclusion and exclusion, and hopefully that will help you in solving such questions. That's all for this video. If you like the content, please subscribe to the channel, share it with your friends, and I'll bring new content for you soon. See you next time.